Thank you for calling my attention to it. I'm so sorry. I think it's slipped my mind.
It's fine. You could just do a quick recap and then continue.
Oh, okay. Okay. So for those that are just joining, we're talking about exceptions, right? And as the name implies, exceptions are unexpected events that occur when our program is being executed. Now, why is exception a very important topic? Because you don't want a case where your program is running and there may be a little error will just cause the whole program to stop running. Meanwhile, if you had just handled that exception, your program will just keep flowing. So that's why we are looking at exceptions. It's actually very important, and nobody is perfect. So there's no way you can say, I'm going to write a program and then I can never have exceptions in my code. It's not possible. So that's why it's actually very important. Then I also mentioned that we have different exception classes in C#. I mentioned the divide by zero exception, which occurs when you're trying to divide a number by zero. An exception will definitely occur. We have out of memory exceptions. We have index out of bound exception. We have stack overflow exception, and also one very common exception, which is no reference exception. And this occurs when you're trying to reference an object that is null. Now, these are not the only exceptions we have. We have so many exceptions in the C# exception class, right? But these are just common ones that we can be familiar with. So I also mentioned the try and catch block. Now, the try and catch block comes into play as a way of handling exceptions. This is how we handle exceptions in C#. Right? So what happens in the try and catch block? You have your main code in your try block, like I displayed here. Okay. Let me show you an example. So say I put this code here in this try block. So you have your code in your try block. So what you're saying is that I want this code to run, but if anything happens, your catch block will handle it, right? And then anything that you want to do after the catch block has picked the exception, you can write it here. So in this case now, I'm going to say, okay, if my catch block, if my exception enters this block, just console write to my console, just console.write an error occurred. Right, so I can do the same thing here, so we can. Yeah. So let me run this and put my breakpoints so we can see when the exception is being caught. As you can see now, an exception occurred. Now, if you can see, it didn't enter this catch block because this catch block specifically catches only null reference exceptions. And what the type of exception that is being thrown here is your divide by zero exception. So that's why it comes to the general catch block, and my program keeps running. As you can see, it just wrote an error occurred, and my program can continue running. So that's what our try and catch block does. Then I think I also mentioned having multiple catch statements, like what I just displayed. So when you have multiple catch statements, we use it to handle different types of exceptions, right? So we use it to handle different types of exceptions. Then I also gave a note that we should always have an invalid catch, you should always be mindful of having invalid catch block. Now you should know that a parameterless catch block is also seen as a catch block that has your exception parameter. So it's not allowed for you to have the same type of multiple catch blocks that are catching the same type of exceptions. It's going to throw a compile time error, right? And also if you're having a parameterless catch block in your try catch statement with other catch blocks, that parameterless catch block should always be the last catch statement as we have it here. Now, if you can see here, we have these catch statements, which catches no reference exceptions, and then these catch statements, which catches general exceptions. Now, if I attempt to have these catch statements before this one, it's going to throw an exception. Let me run. Okay, already we can see that we're having this squiggly line, right? So it won't fly. So this general catch statement should always come at the end. You can have as many catch statements as you want. I can decide to catch my divide by zero exception, right? I can decide to catch it here. Now, why do we use this specific exception, this specific exception type? Sometimes maybe you don't want to return a general message to the user. So you know that if it eventually enters here, you know that it is a null reference, that it's a null reference exception that will code, and you can be able to pass the correct message to the user. Same thing here. If it enters here, you definitely know that it's a divide by zero exception that will code, and you can return a very specific message maybe to the user and say, don't divide by zero. But when you use this exception, this general exception, you can't really pick the particular exception that happened. Now, it's actually possible to pick it, but we'll have to step into the exception class. I don't know if I mentioned it in my notes. I think I must have missed it. So this exception class, with this exception class, you can access the inner exception, right? So let me give you an instance. So say we want to display the message that occurred, right? So you can access the message that occurred by using the exception.message. This displays the exception message. Then we also have exception.inner exception, which displays more details on the exception that occurred too. So let's run this again. Please, if you're not following, kindly call my attention, or if I'm too fast. Running this. So you can see an error occurred, attempted to divide by zero. So we can see that the message returned gave us more specific details on the exception that occurred. Then the inner exception class. Okay, the inner exception class returned null. I'll try to see if we can generate an exception that will produce an inner exception. So I don't know, are you following?
Yes, we are with you.
Okay, thank you. Let me proceed. Yeah, so I've handled this. So now let's look at nesting of try catch. So it's also possible for us to nest our try catch blocks. What I mean by try catch nesting, that means you can have a try catch, and then inside the try block, you can also have another try catch inside. So what happens is that if the exception that is raised in the inner try block is not caught, the outer try block catches it, right? So it is a necessary condition that a try block must be followed by a catch or finally block, because if you use a try block without a catch or finally, then you tend to have a compile time error. So let's look at an example of nested try catch. So this is one. Comment this. This else. Okay. Let me just put, okay. So here we're instantiating the Greek object and we're instantiating it as null. So what I'm trying to do here is I'm trying to generate a null reference exception. If you can see the Greek object here, see this is the object. So it has an author name, and I didn't assign it anything, right? So we have the the geeks object, sorry, instantiated at null, and then I am going to try to assess the author name parameter. I'm trying to assign it when I didn't instantiate this geeks class. So it's definitely going to throw an exception. So the exception is going to be caught by this inner catch statement, right? And my program will run. But if for instance let me stop. If for instance I specify that I only want I want my catch statement here to catch, say divide by 0 exception, right? So definitely it's not going to catch it. So let me run it again. Okay. So it's going to be caught by the outer block catch statement. So this is just an example of how you can nest your try-catch statements, right? And then this logs it in the console. So it's the outer statement that catches it. Yeah, so let's move on. And then we'll be looking at the finally keyword. Now, the finally, in programming, sometimes an exception may cause an error, which ends the current method. Now, maybe that method might have opened a file or a network that needs to be closed. So this is where your finally comes in. It's usually optional. All your try-catch statements mustn't have finally blocks, but we use it when within your try statements, when maybe you possibly opened a file or something and then you need to dispose of the resources that you used, right? Instead of just running your program. So when you have your finally block, any resources that have been used will be disposed of in your finally statement. So in general, it's just a way of cleaning up your code and disposing of unmanaged objects. Now in C#, you can't have multiple finally blocks in the same program. So once you have a try-catch statement, you can only have one finally block, right? So this is, okay, I think this is, yeah, so this is where we're explaining how we use finally. So like we have here, you have your try statement, you have your catch statement, and then you can have your finally. Now this finally block, once once your program runs, it would always step into this finally statement, whether an exception occurs or not, right? Because it's a way of disposing of resources, right? Now, it's also possible for you to use finally block only with a try block, that's without a catch block. But in this situation, you should know that you're not handling any exception. You're just using it as a way of disposing of resources. Now, the finally block will be executed after try and catch blocks, but before control transfers back to its origin. Like I said, before your statement continues running, once your program enters a try catch statement, your finally block must run before your program will continue running. So let's look at this. Let's look at this. This is supposed to throw your divide by 0 exception. And then want to see how it enters the finally block. Yeah. Okay. Continue. So we come here 4 0, then we try to divide. Now we catches the exception. It logs it to the console, and then it still enters our finally block, which logs the statement, right? Then when I mentioned that it's a way of disposing of resources, a very good example is this example where we are trying to read a file, right? So what I'm trying to do here, I'm trying to create a file and read the file and read into the file, right? So if you can see, once I create the file here, it's already taking up resources. But what I'm trying to do is that once I leave this try block, I want my program to dispose of the file resources. And so that's why in this finally statement, I'm now assigning my file as null. Let me run the code so you can have a better understanding of what I'm talking about. Good. Okay, so this is where I instantiate my file object, right? And then I enter my file name. Now I've created a file object. This is it, right? Now you can see that an exception didn't occur, but this file object is still available in my program. Now, if I want to clean up this file object, I can do that in this finally block before I move on with anything I'm doing. So that's just an example of how the finally block is being utilized, right? So and as you can see now, the file info object is now null. So I've cleaned up the resources that was created when I instantiated this file info object. So I think I've touched everything. Yes. So yes, so in summary, I've talked about exceptions, and then when you talk about exceptions and you want to handle exceptions, that's where you have your try and catch your try and catch statement, right? Then when you have your try and catch statement, you can use your generalized catch statement, which is the exception block, whether parameterless or just having your exception, right? This is your general. This is the general way of handling exception. You're referencing the general exception class. But when it gets to the point where, okay, where you want to handle specific exceptions, then you have to familiarize yourselves with the different types of exceptions we have, and then you mention it here, right? When you're creating your catch block, and that way you're catching that specific exception. Then I also mentioned that when you're having multiple catch blocks in your try catch statement, you should also always ensure that if you're having this general catch block, maybe to catch any other exception that might have skipped your mind. Say you have a program, and then it's likely that you can have a no reference exception, you can have and a Stack Overflow exception. But it's also possible that some other exception can occur that you are not aware of. So it's always good to also add this general exception block, which will catch any other exception that can occur. And it should always be the last catch block on your try catch statement, right? Then I also mentioned having your finally block, which is optional, right? It always comes into play if your program is going to be using up resources and you want to release those resources once you're leaving that once you're leaving the try catch block. So that's where you use your finally, that's where you use your finally block, right, to release any resources that your program might have used. Then you should always note that in every instance, whether the catch state, whether your an exception occurs or not, whatever code that is inside your finally statement, inside your finally block would always be executed. So we should always remember that. Then it's also good to know that you can't have a break statement or a return statement in your finally block. You can't have a break statement in your finally block. Yeah, so that's all from me. I don't know if anyone has any questions.
Yes. Thank you very much for this session. I think we have just 2 minutes. Maybe we can use the second call for Q&A. So if there is any.
Okay, so I should create another meeting, right?
Yes, I think we can still reuse this one, or it's not reusable. The link is reusable.
Is it? I don't know.
Okay, no problem.
But does anybody have any questions? So I could let me know if I should create a new link or something. Questions, anybody? Before our time runs out, I'll know if I should go ahead and create a meeting. Okay, so I believe we don't have questions, right? No questions, right? So there will be no need to create another meeting. Can anyone hear me?
Yes, we can. No questions from here.
Okay. Thank you. So thank you, everyone. I'll share the lab with Manuel later. Thanks for joining.
Thank you very much. We really appreciate you.
All right. Yeah.
Thank you very much. Have a nice weekend.
Thank you.